Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss the equation of continuity. So you can see that this is a pipe which is having a flowing liquid inside it, and this liquid is ideal liquid. And by ideal liquid, I mean that this liquid is incompressible, which means that its density remains constant throughout, and this is non-viscous, which means that there is no viscous force acting between the molecules of liquid when it is flowing. So this is an ideal liquid, and this is flowing through a pipe of variable cross-section area. So what we can say that the rate of flow of volume dV by dt, let us suppose that it is Q. So this is rate of volume flow. So obviously, for an ideal liquid, the amount of volume of liquid entering the pipe per second will be exactly equal to the amount of volume of liquid leaving the pipe per second. Okay, so we can say that dV by dt will be constant, and this, let us write down the volume. So volume can be written as A into X, where X is the length of the pipe and A is the area of cross section. So this is Q. So Q will be equal to A into dx by dt. Now dx by dt is the velocity. So we can write down the volume rate flow as A into V. Okay, where A is the cross section of the pipe or streamline, and V is the velocity of flow. So according to this equation of continuity, the amount of volume entering per second into the pipe will be equal to the amount of volume leaving per second through the pipe. So in this scenario, the entering volume per second will be A1 V1 and the volume leaving the pipe per second will be A2 V2. So we can say that A1 V1 will be equal to A2 V2. This is the equation of continuity, and what we can say that A into V will be constant. Okay, which means that if the velocity of liquid flow increases, sorry, then the area of streamline, area of cross section will decrease, or vice versa. Now there is a confusion among the students that whether this equation is the law of conservation of mass or it is the law of conservation of volume. So obviously this is equation of continuity represents the law of conservation of volume only. And if in any case the liquids filled in the pipe has different densities, this is rho 1 and this is rho 2, then also we will say that Q in will be equal to Q out in this case also, and provided that these both liquids should be ideal. And Q in will be let's suppose here the velocity of liquid flow is V1 and here the velocity of liquid flow is V2. So we will say that A1 V1 will be equal to A2 V2. Okay, so this is the equation of continuity in the case when density is not same or liquids filled in the pipe are not same. Now let us discuss a concept illustration problem. Now you can see that this is a buffer and there are three pipes which are joining this buffer, and two pipes are taking the liquid towards the buffer. They are bringing the liquids inside the buffer, and one pipe is taking the liquid out of the buffer. So again, according to equation of continuity, we will say that Q in will be equal to Q out, and Q in will be equal to 2A into V. This is 2A into V plus 3A into V. This is total Q in, and Q out will be equal to A into V dash. So V dash will be equal to 5V. This is the velocity of liquid flowing out of the pipe. Okay, now let us let us discuss a practical situation in which when we are gardening the garden, and in fact when we are giving we are spraying the water through a pipe in the garden, and we just hold the pipe vertically in the upward direction, and the water stream is going in the upward direction. So obviously when this water stream will be going in the upward direction, at the topmost point the velocity will become zero, because this water is going against the gravity. So velocity of flow at the top point will become zero. As we know that A is inversely proportional to V, and therefore if V becomes zero, then A tends to infinity, which means that these molecules will move towards infinity, and they would try to make their area of cross section infinity. But due to constant force of gravity, they will be pulled down and they will follow a projectile path like that. So there will be a fountain which you would see in this case. And obviously when we are when we are spraying the water in the garden through a pipe, and when we press the pipe from the front, then obviously the area of cross section of the pipe is decreased, and the velocity of the liquid flow through the pipe increases. But let me tell you that pressure of the liquid decreases. So this sounds to be strange, but I'll explain this concept by Bernoulli's theorem in the later videos. And in this, obviously you can also see that when you are having a bath, then you can see that the stream in which water is falling from the tap becomes narrower as the water is going in the downward direction, which means that the area of cross section of the stream at the tap and the area of cross section of the stream at the bottom is lower than as compared to the area of cross section at the top, because as this liquid is moving in the downward direction, its velocity is increasing and the area is decreasing, because equation of continuity has to be followed. So this was it in this video, and in the next video we'll be discussing the Bernoulli's theorem. Thank you.